Hey guys, so we had a lot of issues today getting our student videos uploaded, so I'm going to do just a real quick one to kind of summarize today's problem and get you some help if you need it at home. And then we are going to work on those student videos and getting those uploaded. We'll figure that all out, so next time I'm not the one doing these videos, it'll be you guys doing it. So you should have in your notebook this chart with all of our fractions. We placed our fractions and mixed numbers on a number line. We even had some negative fractions. We placed them on our number line, told what benchmarks they were between. Were they between 0 and a half, half and a 1, and so on. And then we filled out this bottom part of the table and told which benchmark they were closer to. And some we found were in the halfway mark, and that's these that are circled, okay? So you guys have that with you. Here's mine just to remind you. Refer back to this if you need to and use it on your problems today, okay? So we're going to look at problem 3.2, and here are all of your problems. You can also access your book on pearsonrealize.com online. Most of you should have this with you today, so you should have your hard copy book with you when you're working through these problems. So problem B says insert a less than, a greater than, or an equal to symbol in each sentence below. Explain how the numbers or the number line helped you decide. So on number 1, you've got -5 halves and 3. So on my paper, you have to decide -5 halves and 3, which one is greater. And if you use your number line, looking here, I know that +3 is going to be down here. -5 halves, we didn't actually have that one on here. But if we want to, we can turn this back into an a mixed number. So this is actually going to be -2.5, right? Because if you divide 5 by 2, 2 goes into 5 2 whole times with 1 left over, and then we just leave the denominator the same. So which is greater, -2.5 or 3? Well, you might be sitting here and just comparing the 2.5 and the 3, and that's fine, but you really need to just pay attention to these symbols in the front, the negative and the positive, because anytime we have a negative number and we're comparing it to a positive number, negative numbers are always smaller than positive numbers, okay? So without even having to figure this one out, I know that 3 is greater than -5 halves, or -2.5, okay? And this is how I use my number line. So in your explanation, you'll add your explanation on here about how you use your number line, and you can just draw a short number line if you want to. Or you can even talk about negative numbers are always less than positive numbers, okay? So that's what you're doing on 1, 2, and 3. On number 4, Callum says that every number is greater than its opposite. Do you agree? And explain. So for example, that was number 4. If we had, let's just use 3. If we had a +3 and we had -3, he's saying that every number is greater than its opposite. So every number, 3, is greater than its opposite, -3, just like 4 would be greater than -4, or 10 would be greater than -10. And so it's asking, do you agree? So yes or no, and why? Why do you agree? Well, we kind of talked about that up here, about how negative numbers are always smaller than positive numbers. So you can talk about that and use your number line again in your explanation, okay? And then we'll share that tomorrow and go over that. Number 5, Blake says that he can use absolute value to help order the numbers, -6/5 and -2/3. He says the absolute value of -6/5 is greater, so it is farther away from 0, and therefore -6/5 is less than -2/3. Do you agree and explain? So here he's talking about the absolute value, okay? And he's kind of come up with this strategy, and so we're going to see if it works. So he says, let's see, that's number 5. He says that the absolute value of -6/5 is greater than the absolute value of -2/3. Okay, so he says, and then remember, these lines mean absolute value. And we know that absolute value, all it does is just turns this number into a positive number. Okay, so we have 6/5 and 2/3. This absolute value, it just changes a negative number to a positive number. Okay, it stays the same, just changes the symbol. Now, if it was positive 6/5 and we wanted the absolute value of positive 6/5, it would still be a positive 6/5, okay? So absolute value of a number is always going to be the positive value of that number. So, it says that since the absolute value of 6/5 is greater than 2/3 because 6/5 is farther away from 0. Well, if you're looking at your number line on 0, we know that 2/3, let's say if we have 0, we have 1, we know that 1 is equivalent to 3/3, right? And we know 2/3 is going to be about right there. So 6/5, well, we know 5/5 is a whole, so 6/5 is going to be somewhere over here, right? So 6/5 is farther from 0, and it's greater according to his model here. So when we look at these negative numbers that he was really dealing with originally, let's say if we have a -1 here, our negative 2/3 would be, remember, these number lines are symmetrical, so it would be basically laid out the same way as it is on the positive side, just on the opposite side. So do you agree with his strategy here of using the absolute value to determine which one is bigger? Because he's saying that negative 6/5 is smaller than negative 2/3. And remember, if we look at our number line, the farther away from 0 you go on the negative side, the numbers get smaller. So he is correct, right? So tell me why you agree with him. Explain your reasoning there, okay? Number 6, will Blake's strategy work for all of the comparisons you did in questions 1 through 3? So does this strategy he used here work for all of these comparisons we did up here? So look back at your answers and see, it worked here for the comparison he was making between negative 6/5 and negative 2/3. But does it work for every set of numbers? Okay, so I want you to show me some examples and write your explanation there. Just do the best you can on that one, and we're going to talk about that one tomorrow. Now in C, compare each of pair of fractions using benchmarks and other strategies. Then copy the fractions and insert a less than, greater than, or equal to symbol to describe your strategies. So basically, tell me which one is greater than, less than. Put the correct symbol in here, okay? And then just tell me how you knew that. Did you use, the number line and the benchmarks like we did here? Maybe if you had an improper fraction, maybe you turned it back into a mixed number and then use the number line. So just give me your answer and then kind of talk about what you did to solve that. What was your thinking that helped you solve that, okay? So that's C, 1 through 6 there. D says the smartphone screen shows deposits to and withdrawals from Brian's checking account. Okay, so he's got some money. He's been spending some money. Another student and I think it was Chase, we were talking about these negative numbers mean, hey, that's days when he spent money. Okay, a deposit are days he got paid or made some money, okay? So number 1, which account activities have the same absolute value? What information does this provide for Brian? Okay, I'm going to let you do that one on your own. I think you can handle it. So remember, those absolute value makes every number a positive number. Okay, so number 2, Brian says that he spent less money on October 27th than he did on October 21st because the absolute value of the account withdrawal is closer to 0. Do you agree? So he's saying he spent more money here, less money here than he did here because this number is closer to 0 than this number. So you might draw out your number line and plot these points on there and tell me, yes, I agree, or no, I don't agree, and explain why. Okay, so do the best you can on your work tonight. If you have any questions, we'll go over this tomorrow, and we'll work on those student videos.